Okay, now we will move towards the problem statement and the problem solution. Okay, now we we have Ali wants to build a pool in his backyard. He wants to build a pool, an adult pool with volume 2,400 cube. His friend suggests he build a rectangular pool so that he can fit in the depth is labeled as y and the width is x. The length of the pool is 3 times the width. Ali wants to measure the depth, the length, and the width of the pool so he can start to plan his pool. He also needs to know the minimum surface area for his pool to fit in his backyard so he can save some money for the tile. Okay, now we will highlight some points here. So you can see it's given the volume is 2,400 cube. The pool, the shape of pool is rectangular, and the labels y, x, and 3x. So now we will want to sketch the rectangular pool like this, and label the depth is y, the width is x, and the length is 3 times x. So now, since we have the volume, we have to find the formula for the pool. Formula for rectangular is length times width times height. The height is equal to depth. So here we will substitute it with 3x and x and y equals to 2,400 meter cube. And so now we have the volume formula, and we get y from it. Now we have to search for the surface area. For the surface area, this pool have open top, which is the water will fill in the pool, and the top is open. So the surface area will be counted from the front and back, the side, the two side, and the base of the pool. So as you can see, the surface area, this is for the front and the back. This for the left side and the right side. This for the base. So when we substitute the numbers and the labels, lastly we will substitute the y value in the formula. We will get surface area formula here. For the step 1, we have to find the derivative. Okay, so from the surface area formula, we will find the derivative. You will get negative 6,400 divided by x squared plus 6x. And then for step 2, let dA over dx equal to 0. And you will get the x value, which is the x value is 10.22 meters. After we get the x value for this step 3, we will which is find the second derivative and test the second derivative. So from the first derivative, you will have to derivative it once again to get the second derivative, and then substitute the x value in the second derivative. If the value of x is higher than 0, is larger than 0, then the value is a minimum value. If it's smaller than 0, which is negative, it will be the maximum value. After that, you will determine the x value is minimum or maximum value. After we determine whether it is minimum or maximum value, you will have to substitute the value of x into y to get the y value. So the y value here is the formula that we get in the first place from the volume. Okay, so you just have to substitute the x value in the y formula. So after you substitute the x value, you will get 7.66 meter for y value. So the width here is x, which is 10.22 meter. The depth is y, which is 7.66 meter, and the length is 3 times x, which is 3 times width. When we substitute the value of x, you will get 30.66 meter. Okay, that's for finding width, depth, and length. So next we move to finding the minimum surface area of the pool. So to find the minimum surface area, you will have to use the surface area minimum surface area formula that we get to substitute the value of x in the formula, and then you will get the a minimum. That's the answer for this problem statement.